Hello, chickadees and chickadoos. All right, today is Tuesday the 30th. We had our math tutorials today. Speaking of math, we continued our lesson on perimeter, and we've been working in 12.3. So go ahead, get your math book out. Let me turn to that page. It is 400. 12.4, 12.3. All right, so it is on page 422. Hold on, I came unplugged somehow. Let's try this again. That's connected. That's connected. What is going on? Oh, I got it. Maybe. All right, let's try this again. There we go. All right, back in business. All right, so on page 422, we started up here at the top, and we're using, it says a formula is a mathematical rule. You can use a formula to find perimeter. So this is one of the ones that you can use, 2 times L plus 2 times W. So you have your length, and you have 2 of the lengths, so that's why we're taking 1 and multiplying it by 2. Same thing here, you have 2 widths, these opposite shorter sides, so that's why we're multiplying 2 times the width, and then perimeters add up all the sides, so that's why we're adding those 2 amounts. So here we found the perimeter of the rectangle. Since this side was 18, opposite was 18. Since this side was 14, the opposite was 14. And then we plugged it in. So we have perimeter equals 2 times the length plus 2 times the width. You write the formula first. Then you start plugging in what you know. We know that the length is 18, so instead of writing L, we can just put 18. And we know that W stands for width, and we have the width 14, so instead of writing W, we could put 14. Then we know 2 times 18 is 36. 2 times 14 is 28, so we write that on the next one. And then we know that 36 plus 28 is 64. So our perimeter is 64. So you start and you just keep building and building, and you just keep going and going. And as you keep moving down the line, you're plugging in those things that you learn. So once you have the length, you plug it in. Once you have the width, you plug it in. Then you say to yourself, okay, I know I can do that and I can do this. So then you plug it in. Then you say, okay, I know I can add that, plug it in. So you just keep going down the line. All right, here, we took this shape here. We've got 8 and 4. So we wrote down the formula, plugged it in, multiplied it out, and then added to get our perimeter. Here's the formulas on the side here. So since we're using a rectangle, we went to the formula for a rectangle. All right, so down here on the bottom, we tried 3 different ways of finding perimeter. So the first one, the first thing we learned is that we can just add. We don't have to multiply. We don't have to do all that. We can just add up all the sides. So if you have 4 sides, you need to add up all 4 of them. So 16 plus 16 plus 4 plus 4. Now this only gave us 2 of them, so we had to go in and we had to find the missing one. So if this was 16, we needed to find the opposite over here at 16. Since this one was 4, we had to find the opposite 4. So when we added up all those 4 sides, we got 40. Then here, same thing. We're finding the perimeter of a rectangle. This time we went with this other formula. We've talked about how mathematicians, we like the easy way of doing things, the short and the quicker way. So instead of writing 2 times L, we put the 2 and the L side by side, which means the exact same thing, and the 2 times W, the 2 and the W side by side. So whenever you see things side by side to each other, that means that you're multiplying them. So 2L plus 2W, you plug in what you know the length is the 110. So 2 times 110 plus the 42 here is the width. So instead of W, we're going to plug in the width, 2 times the width. 2 times 110 is 220. 2 times 42 is 84. Add them up, and you get 304. All right, so we worked on those. Then we went to Google Classroom. And under classwork, you have an activity that says Monday through Friday, perimeter and area. Now, this is going to be a 2-week assignment because we have not done area yet. We have only done perimeter. So the pages and anywhere on the pages that says area, we're going to save this for next week. So you're going to skip page 1, you're going to go down to page 2, and you're going to look at the ones that say perimeter. Okay, so we were checking out some of those together. This next one's area. This next one is area and perimeter. So you're going to skip the area part and you're going to look at perimeter. So you're looking at the outside, and these shapes are not always going to be squares and rectangles. They could be, these are called composite figures. You can still find the perimeter. You just count on the outside. So 1, 2, 3, 4, and you go all the way around. Okay, so same thing on this one. Anywhere you see area and perimeter, just stick with the perimeter one for this week. So we worked on those. Then going back to the agenda, there is a website here called Adam Ant. This is just a kind of a self-checking practice. So Adam the Ant, he's going to walk around, and as he's walking around, he's calculating the perimeter. So 2 plus 4 is 6. Then he goes down this side, which is 2, so that'd be 2 more would be 8. Then he goes across this side, which would be 4 more. So then you put in your answer, 12, and you check, and it says, super, you really know your perimeters. Okay, so then you click the arrow to keep going. So it's just a little self-check, just practicing. And I really like how the ant walks around because it's a good visual to show perimeter. We're talking about the outside of the shape. These are just some questions to think about. You can click on this and look through these. Just some questions to think about when you're solving. So do you know what shape you're being asked about? What important information about the measurements was given to you in the problem? What formula is going to help you solve this problem? What information is missing? What is this question asking? Okay, so we'll keep referencing back and thinking about those as we move through this unit. In reading today, we played a nonfiction review game. So we were looking at, it was a Jeopardy game that we played together. And this time the topics were on nonfiction passages. Then we read a little, or we finished, and so I can take this out because we finished our book. So next week we're going to start Fudgemania. So we finished the Wild Robot, and so we are all set to do our Wild Robot activities. So if you go down to week 29, reading week 29 here, open up. All right, so these first few pages are the recording sheets where we're putting from our game. So tomorrow we'll do the poetry one. So today was this page 2 with the nonfiction. And then the rest of the pages are the things that you're filling out about the Wild Robot. So it says, as we finish up the Wild Robot, I'd like to hear what you thought about the book. Answer the following on the next page. So there's 4 questions here. You're going to put your responses here. So 1, 2, 3, 4. Then on page 6, you could go to his website and browse his website. I want you checking out the other titles. You might find something else that you recognize that you didn't know was from him, or you might find something you're like, hey, I wanna go check out that from the library, or I wanna see if I can get this to read next. One of the books on there is called Children Make Terrible Pets. You can go to Epic and you can listen. It's an audio book, so it's not going to show you the photos, but you can listen to the story. And it's just a picture book, so it won't take too long. And then page 7, you're putting your writing response here. So you're putting yourself in Bright Bill's shoes, meaning you're thinking like as if you are Bright Bill. What would it be like having a robot like Roz for a mother? So think about all of their interactions, how they communicate with each other, the things that she does for him, the things, just their whole relationship. Put yourself in his position. What would it be like if your mom was a robot? So put your response there. And then here's Peter Brown. He's the author of The Wild Robot. So I would like you to interview him. What 5 questions can you come up with, and type them out here. And I'm going to pick some really good ones, and we're going to tweet them out to Peter Brown and see if he will respond to us on Twitter. So think of something really creative and put those there. All right, when you're done, now that we're done with the book, you can, well, actually, we need to wait till we're done with poetry. So tomorrow we'll be able to start turning this in, and then everything will be officially done by Friday. Well, we'll be done early, but you can take till Friday if you need. All right, so I'm going to draft this and then head over here to writing. So we're going to go right back to here and open up our writing. And in writing today, we did the passage from Carrot Tops to Compost, and that's in Seesaw. And then for our Women's Month project, yesterday we developed our questions. So we were coming up with questions that we could ask a woman in our own personal life, and just getting some opinions on, what do you think about, why we celebrate Women's Day or Women's Month, like why we have a Women's Month, talking about the history and how far women have come, and maybe different some challenges and things that we may not think about because things today aren't quite like they used to be, but there's still some challenges. So just having those conversations with someone in your life, and kind of getting their take on things and their opinion, and just talking with someone close to you about that. So I want you to today make sure that you interview your person and start working on your draft. So you have free choice of how you present this. You could do a video. You could do a video of actually showing them or just recording their voice. You could type it up. However you want to share it, that's completely, I'm leaving the creative side up to you guys. So you guys come up with how you want to share it, and then start, you had time to work on that today, and then we're going to start sharing tomorrow, and then we may have to save some of them till next week if we don't finish, because tomorrow's testing, so tomorrow's going to be busy. So you guys know how those 4-hour tests goes. They kind of suck up the whole day. So if we have time, I'd like to share tomorrow. If not, we'll just push it into next week, because on Thursday we're going to be working on our composition. So we'll kind of just play it by ear and see how it goes, but try to make sure you're working on that. So for writing, we did the carrot one. So we talked about the questions, talked about the strategy of how to solve them. We broke off into groups, and then we came back, and this is what we came up with. So here, what is the best way, if any, to combine sentences 8 and 9? The only thing, when you go and you highlight sentence 8, it says, now spray the ground with water. The only place that I could find that was in, I can't tell if I think that's B. Now spray the ground with water, here in pink. And then sentence 9, and add the layer of grass. All of that is right here in blue. The other ones, they really mixed up all of the words. They had some removed. They were in a different spot. That's when you combine sentences, you're just bringing the two together. Okay, so it's like you're sliding them together. You're removing that period, fixing the capitalization, and just kind of joining them together. So we write that word join above the word combine to help us remember that we're joining them together to combine them. And you're really looking, our strategy to solve this kind of question is thinking about, what from the first sentence is there, what from the second sentence is there, and how they brought them, and just looking at how they brought them together. Now, this one, it had a fanboy, but the reason we don't need that comma is because we don't have two separate sentences. If we had two separate sentences, then we would need to join them with the fanboy and the comma. But since they are not, we don't need that comma there. Number 2 says, which of the following could best follow and support sentence 11? Here's sentence 11. So we put this little line in to show that that's where we're going to insert our sentence in. So F, G, H, or J is going to be inserted in, and it needs to follow. So when you write something and you say something like, always use more green material than brown, you need to explain yourself. So the only one that fit and was a good explanation of what we're talking about with this compost was that green material adds nitrogen to the compost. So that there gave a good reason why we need to do that. Okay. Number 3, it says Charlie wants to move sentence 14. Sentence 14 says, first, you should make a plan. Something that says first cannot be at the end of your paper. It has to be first at the beginning. So we said after sentence 1 right here was a good place for it to be. So you can recycle by building a compost bin. First, you should make a plan. Okay, so when you go and you plug that in, you need to read it and you need to check, okay, is this a good fit here? A lot of us were putting it in, like over here before sentence 3 or before sentence 5. And when you read it through, you had already listed all these steps and things that you're doing, and then you say first. And so I gave the example in class where I said, if you're getting ready, if I say, I'm giving you instructions of how to get ready in the morning, and I say, okay, Lindsay, go and brush your teeth, eat your breakfast, make sure you eat your breakfast, brush your teeth, first, get dressed. Well, that doesn't make sense because I said first as my third thing to do. If I want you to go get dressed first, I need to say it first. So anything that has first with it, we need to put that at the top. It has to flow. Okay. Number 4 says, which sentence in Charlie's paper does not contain a complete thought? We said that was number 2, away from the house. That was not a complete sentence. We don't know what that's talking about. It's kind of random and thrown in there. So we chose that one. All right, moving on. Science. We continued our review for science. So here is what that looks like. So let me go over this. So yesterday we started this first copy in our intervention time. So I'm gonna show it. I'm not gonna go through it super slow. So pause the video so you can make sure you get all this. So you've got water cycle, magnets, seasons, conductors, and insulators. Okay, so pause it after each one of those. Same thing on the back. We've got friction, shadows, weathering, erosion, and deposition, forms of energy, and renewable and non-renewable resources. So let's talk about these quickly. So water cycle, the sun is our powerhouse. If we don't have the sun, we don't have a water cycle. So the sun, we've got that thermal energy. It heats the liquid. It turns it into a gas known as water vapor, causes the process of evaporation to happen. Evaporation is that gas. We rise up into the air due to density, and the gas changes to a liquid. That process is called condensation. This is where our clouds are. So think condensation starts with the C, cloud starts with the C. Then it falls as a form of either rain, snow, sleet, hail, depending on the temperature, and that process is called precipitation. Magnets, you probably heard the saying, opposites attract. So when we have opposites, these are going to be attracted together, meaning they're going to come together, they're going to join, versus here we've got north and north or south and south. If we have the same poles, they're going to repel, meaning they're going to push away from each other. Think about when you put on a bug repellent, you don't want the mosquitoes and the bugs to come to you. You want to repel them. You want to push them away. Okay, so repel, they're pushing away from each other. Conductors and insulators, if it's open, it's broken. If it's closed, it flows. So we did a lab in science where we made a circuit. We had a battery, a light bulb, and we left this, and the wires, and then we left this gap open. And we said the only thing that would turn on the light bulb is when we close. Remember, if it's closed, it flows, meaning those electrons are flowing all around the circuit. And the only thing that would work when we would insert it in were things that were conductors. So conductors are things that most of our metals and things like that are conductors. And insulators are the opposite. So when we put something plastic, wood, rubber, or glass, and we tried to close it, those electrons were not flowing all the way through. So it was like it was still open. If you have any kind of opening or any kind of insulator in here, we say it's open, it's broken, meaning the light bulb is not going to turn on. The only time your light bulb's going to turn on is when you have that conductor in there. All right, seasons. Seasons, we've got our sun, we've got earth in 4 different positions. We've got our tilt. The reason for the seasons is the tilt. Here you have the northern hemisphere, the southern hemisphere. The sun is shining and we've got direct sunlight hitting the southern hemisphere. So because it's receiving that direct sunlight, it's having summer, versus the northern hemisphere is tilted away, they're having winter. These middle positions here are always going to be your summer and your winter, okay? The top and the bottom are always going to be your spring and fall. So once you figure out this middle part, then you could go around and you can say, okay, after winter we have spring, after spring we have summer, after summer we have fall, after fall we have winter, and you can go around and plug in the rest. But please remember, these middle 2 positions, winter and summer, and we know which one is which because of that direct sunlight. So if the southern hemisphere is getting the direct light, summer. Here, the reason why the northern hemisphere is getting summer is because now that is getting direct sunlight at the northern hemisphere. So the northern is tilted towards, the southern hemisphere is tilted away. So now they're experiencing winter. All right, next, friction. All right, friction is an opposing force. If the motion of this soccer ball is going to the right, friction is going to work and it's going to be an opposing force. So friction is going to work the opposite direction and push against it. If we have 3 ramps here, we've got ice, sandpaper, grass. Ice is going to have the least amount of friction, so it's going to go down the fastest, versus the sandpaper and the grass are going to move down the ramp a lot slower because these are really rough surfaces and they have a lot more friction. So the more friction you have, it's not going to go down as quickly as this ball would on the ice. All right, in the middle here, weathering, breaks it, erosion, takes it, deposition. When the motion stops, deposition drops. So when you see the word, anything to do with breaking, and we're talking about Earth's surface, so anytime you have a break, that's the process of weathering. Anytime you have something that is now, so you've got pieces, like let's say we've got a rock, and you've got pieces, so let me draw a little rock. All right, so wind, water, ice, something causes a break to happen. And you get these little pieces of sediment that have broken off. Well, wind, water, and ice, or gravity, could also be responsible for taking it to a new place. Wind comes, maybe the water in an ocean, something, the waves are moving. It's going to take this sediment and move it to a new place. That's erosion, so any kind of movement. Deposition is when it stops moving and it gets deposited in a new place. That's deposition. So deposition drops it, and now it's in a new spot. All right, renewable and non-renewable resources. You have two categories for Earth's resources. They can either be renewable, meaning they can be easily replaced, like our trees and plants and animals, or they can be non-renewable, meaning they can not be easily replaced. Things like minerals, your fossil fuels, coal, oil, natural gas, these things take a very long time to form. They do not form. We will not see them replaced in our lifetime. They take millions of years, and because of that, we call them non-renewable resources. That non means that they are not renewable. So con, rhymes with non. So remember con, coal, oil, natural gas. Those are your fossil fuels. All right, forms of energy. We talked about the different forms of energy that we've talked about this year. So thermal has to do with heat, light, electrical, mechanical is anything that has movement, and then sound energy. So let's say we have a TV. We said that, sometimes we can feel the TV when it's been on for a while. It might feel kind of warm, giving off thermal heat. It gives off a light. We have to plug it in, so it's electrical. And then it gives off sound, so it has sound energy. None of the parts, now the stuff on screen, yes, that's moving. But when we say something that has mechanical energy, like I gave the example of glasses, how I can move, and these have parts in here that allow the glasses to move, or like my whiteout here, it has the ability to twist open. Okay, so things like that, or my scissors. My scissors have the ability to move and I can open them. That's an example of mechanical energy. Things on here, none of these parts are actually moving, so we didn't check that off. And I think that is it. All right, so that is a quick little review of the fourth grade science that we've done so far this year. So study this tonight before you go to bed, and then maybe tomorrow before our test, look over it one more time, so you'll be all set and ready to go for our science benchmark, which is tomorrow. All right. Last up, we did social studies, so we went over the article and questions for today. There's a video here you can watch. And then for our intervention time, I met with the people coming in for STAR, and we were looking at some of the tools that we are going to use on the program that we're using for the STAR test. Tomorrow, we've got National Crown Day, so we're going to wear our favorite color shirt. We have our science benchmark, so we're going to switch specials with third, and we have specials at 12:15. So we will go. So Miss Snyder's Zoom will go till 2:50. Okay, so we'll be on Zoom together till 2:50. So this whole schedule, ignore the times, because this whole schedule is going to be, we're going to have to play it by ear. Okay, so we'll see what we get to. The science test, we have technically 4 hours. The sooner that, some kids have the ability to test all day. So it just kind of depends on how long it takes us to finish up our benchmark. That doesn't mean I want you to rush. That just means I want you to, take your time and do your best. And if it takes you 4 hours, it takes you 4 hours. If it takes you 1.5, then it takes you 1.5. But so we'll just have to play it by ear and kind of see how our schedule goes. And if we need to adjust, then we will adjust and just be flexible for tomorrow. But make sure you're on time. 7:45 is when that tardy bell goes off. So make sure you are ready to go. 7:45, everybody should be logged in. And then we will start directions and get going. And then hopefully we will have started technically testing around 8, a little shortly after we finish the directions. So Please be on time, and I will see you tomorrow. Bye, guys.